Good morning, everyone.
Morning, sir.
So, how was your weekend?
Fine, sir.
Fine, okay. What was your class from 10:30 to 11:15?
Physics.
Huh?
Physics.
Physics, okay. Okay, because why I'm asking why there are only 11 people so far, 12 now. You are having a gap of 15 minutes between each classes, so it's enough time to whatever you want to freshen up. You have tea, coffee, or whatever, go to the toilet and all. So don't delay. Okay. I still have only 15 people, and all this is on the record. Huh? The meeting is already being recorded. I put the recording on, so just for your information also. Now I have 16 people only at the moment. I will have to check in the record who all are joining later. Okay, here you can see up to 11:33 who all had joined, you know. You can see the Excel sheet.
Yes, sir.
Yeah. So we know who is joining what time. So I request everyone, don't delay. When you know that there is a lecture at 11:30, okay, 1 minute here and there maximum, but you should try to join in time. Okay. Don't delay next time. Otherwise, I'll have to, of course, do some action then. Okay. Now let's see how many. Okay, now still we have only 19 people, not even half the class. Just be reminded again that you will have to attend these lectures again after you join in, after the college opens, and don't start crying at that time if you are told to take the lecture at that time. Okay, so be careful. Tell all your friends to be in the time for the class. Okay, coming back to the PPT. So in the unit 3, this is the first topic: solar system, rotation and revolution. Okay. Now Okay, how many planets are there in the solar system?
Eight.
Just write down your answers in the chat. How many? 8 or 9 or whatever. Saftar says 8. What about the other people? Okay. Okay, good. Anyway, so, whether you want to call it 8 or you want to call it 9, even 9, I would say still, we would still accept it because it's still considered a dwarf planet. I mean, so they're still calling it a dwarf planet. So, we can name it 9 also. And who can give me the sequence, starting from the sun, what are the planets? Yes, somebody write down in that chat. Starting from the sun, what are the planets? In which sequence which sequence are their orbits? Mercury, Sadr Khurshid. All other people agree to that sequence? What Sabdar has written? Are you sure that what Sabdar Khurshid has written is all correct? Sahil has written. Venus, Neptune, Pluto. Okay. Okay. So all of you are mostly correct. So let's start with this. So basically, what is the solar system? Solar system is consisting of the sun. And what is the sun? Sun is a planet or what?
A star.
Yeah, sun is a star. Okay. So we have the sun, the planets, the satellites of these planets, asteroids, comets, and meteors. And obviously, the most important member of the solar system is the sun. As the name suggests, it is the solar system. Solar is basically the sun. So it is the system of the sun. In mass, it is more than 700 times larger than all other bodies of the solar system taken together. So if we include all this Earth, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, whatever, all this together into 700, that would give us the mass of the sun. Okay. It has a diameter of about 865,000 miles. Okay. Sun is the only body in the solar system which radiates heat. It rotates on its own axis. Completing one rotation is about 25 days. So it is actually the sun is also rotating on its own axis. Earth is rotating, sun is rotating, Earth is rotating on its own axis and also is going around the sun in an elliptical orbit, which is called the equinoctial. Or it's called the elliptic, which in which the the sun is moving, or the sun moves. Actually, the sun is moving in the elliptic, not the Earth. Okay. So, but the sun is moving on its own axis, completing one rotation in about 25 days. And how much time does the Earth takes to rotate?
24 hours. 23 and a half.
23 and a half.
365 days.
No, on its own axis.
rotate it.
24 hours.
Okay. I will take that answer 24 hours, but actually it is 23 hours and 56 minutes. Why we can call it 24 hours, a little different reason. It is not there in the syllabus, but probably you will read it and try to understand it in the second year or third year. I'm not sure which SEM it is falling. Okay, what is happening is actually, it is rotating on its own axis in 23 hours 56 minutes, but it has also moved ahead in its orbit. Okay, so basically to come back to the same position is taking a little 4 minutes more, and that's how it is counted as 24 hours. But actually on its own axis, it is only 23 hours 56 minutes. These are the planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. Pluto has been removed now. Whatever you want to call dwarf planet or non-planet or whatever. So now we have only 8, and of course this is an old one. I had this picture. I think I showed you in the class also. So Pluto is still shown in this, but we can just disregard Pluto, and that is how the planets orbits. Now, when we are talking about the solar system, the most important is Sun, and after that it is the 9 planets. These 9 planets. Planets are not self-luminous. That means we do not get the light. We do not have the light of our own. It is basically the sun which is giving us the light. Okay. So, and also the other planets, why we are able to see them is because the light that they are receiving from the sun, that is getting reflected. In fact, anything what we see is mainly because the light is getting reflected from that particular, let's say in your room, if it is dark, and if you do not have any source of light, let's say a bulb or a tube light or anything, you will not be able to see anything. It's only when you switch on the light and that light gets reflected from a particular object that you are able to see, during the dark hours, even inside a room. So similarly, the light that is reflected by the planets, that's what makes us see those planets. Okay. So due to this fact also, when viewed through a powerful telescope, it will be seen that they also exhibit phases like moon. Like it is not the same thing what we will be seeing, let's say for Mars or this thing, Venus and all that. All these planets, you will see they have a different surface will be visible to us if you watch them using a telescope. Okay, between the orbits of Mars and Jupiter, there are large number of minor planets called asteroids. Okay, it's between Mars and Jupiter. That is what is asteroids. This table, best is to keep a printout of this, because you're going to be using this all through your this thing 3 years, all through the 3 years. Some of the other time you will be required to use this, or at least refer to it. Use it in the sense, refer to it, like what is the period of revolution around the sun, or what is the distance or diameter or period of rotation. Okay, so what is the difference between rotation and revolution? Everybody's clear what is the rotation and revolution?
Yes, sir.
Anybody who does not understand the difference between rotation and revolution, just say no, or just just put in the chat N. Okay, anybody who does not understand the difference between the rotation and the revolution, just write down N in the chat. Okay, so I assume no, I am not getting any notes, so I believe that everybody is clear what exactly is the difference between the rotation and the revolution. So let's go on to the next one. Now, of course, the table we cannot see. So, but there are some planets Mercury, Venus, Earth, and Mars, and the 4 large planets in the outer group, Jupiter, Saturn, Uranus, Neptune, and Pluto. The 2 planets, Mercury and Venus, they are called the inferior planets because their orbit is closer to the Sun in comparison to the Earth. Okay, so they are, these planets, Mercury and Venus, their orbit is closer to the Sun with respect to the Earth, and they are called inferior planets. Whereas the other 6 planets or other 5 planets whose orbit is away from the Earth, or at a more distance than the Earth's orbit, and those are called the superior planets. It's a very simple thing, simple logic, like which are towards the more closer to the Sun are inferior, and which are away from the Sun are the superior planets. So we have the Mercury and Venus as inferior, and the other 4 planets apart from the Earth, or 5 planets apart from the Earth, are the superior planets. All planets revolve around the Sun in a counterclockwise direction. Okay, they are not rotating in a clockwise direction. They are all going around in a counterclockwise. That means anti-clockwise direction in elliptical orbits. And what is a ellipse? That we'll see later on, or I can tell you now also. That means at any given time, the ellipse has a 2 focus, and at any given time, the distance from the 2 focus is constant. Like, if you take the distance from one and the other one, so that sum of that will be constant. Okay. And they're also rotating on their own axis. Like the Earth is rotating on their own axis, the planets also are rotating on their own axis and also revolving around the Sun. Now let's go to this Kepler's laws of motion. Everybody is awake, no?
Yes, sir.
Yeah.
Yes, sir.
Just everybody write yes in the chat, huh? So I know everybody is present there. Or they've just joined and gone back somewhere to do their own job. Okay, just type yes, Y in the chat. Only Y, huh? Okay, because these things, Kepler laws, you must, they're a little bit, haywire to remember. I mean, little bit, I won't say difficult, but if you understand them, then it's very easy to put them in the words. You will be easy to understand. I mean, it's not difficult to understand what the laws given by the Kepler are, but if you understand, then probably you can put them in your own words. Okay, Kepler's laws of planetary motion describe the motion of planets in the solar system. They were derived by the German astronomer Johannes Kepler, whose analysis of the observations of the 16th century Danish astronomer Tycho Brahe enabled him to announce his 2 laws in the year 1609, and third, nearly a decade later in 1618. That means his first 2 laws he gave in 1609, and the third law he came out with after 9 years after that. So you can imagine almost 400 years ago he had put down these laws. Even now for us to imagine those kind of things is very difficult, but these scientists were able to frame these laws almost 400 years ago. Kepler himself never numbered these laws, specifically distinguished them from other discoveries. That means it was never his convention that, okay, this is law number 1, this is law number 2, but probably it has been done so in the later period. Okay, like what is the Kepler's first law, what is the second law, and all that. He never gave that thing. Now, the first law: all planets move around the Sun in elliptical orbits, having the Sun as one of the foci. Okay. So this is the first law, that all planets are moving around the Sun in elliptical orbit, having the Sun as one of the foci. Now, I think in the next this thing, what is the foci is this one. An ellipse has 2 focus points. The word foci, pronounced as foci, is the plural of focus. Okay, so these are basically focus 1 and focus 2, and combined or jointly they are called foci. That means foci is the plural for focus. So both of them together will be called as foci. Okay, the foci always lies on the major axis. Obviously, if this is the ellipse, this is the major axis, which is the larger one or the longer one, and this is a minor axis. Okay, the foci always lies on the major axis. If the major axis and the minor axis is the same length, the figure is called circle. Like if it was a circle, then of course all this axis and this axis would have been equal, but that is not the case here, and that is what, if this major axis is larger and this minor axis will be smaller, and that is what we are calling as a ellipse. Okay. Note how the major axis is always the longest one. So if you make the ellipse narrow, it will be the vertical axis instead of a horizontal one. Okay, I mean you can rotate it 90 degree. That also still it will be an ellipse. Okay, the only thing is that it will become vertical. The major axis will be, in that case, the vertical. It's not necessary that it has to be in the horizontal one. It can be in the vertical plane also. Okay, so that is what it is. Now this is ellipse. Now let's go back to this. What he meant. The first law: all planets move around the sun in elliptical orbit, having the sun as one of the foci, at one of the foci. Okay, so that means when they were moving around, always the sun is either at one of the foci. Okay, that means they are so much of distance away that it can be calculated that it is at one of the focus of the ellipse. Okay, so that is what the first law is about. Now, how to calculate? I had just put it, but it's not really required. And but just for your reference, if you want to calculate, how to calculate is given there. Okay. Now the second law. The radius vector joining any planet to the sun, okay, sweeps out equal areas and equal length of time. Now, what is the radius? What is the vector, first of all? I hope, or I'm sure everybody understands the concept of vector. Say yes or no. Everybody knows
Yes,
now.
sir.
Okay, what is a vector? What are the components of vector?
Having both magnitude and direction.
Yes, correct. Okay, so in this case, the radius vectors are, I have not, there are no names given here, but starting from the sun to the ellipse, that is a radius, no, for a sun, for a circle. So that is the radius vector. So that means this is sweeping the equal area and equal length of time. Okay, let's say in 1 month, if this vector is moving so much, so in this 1 month, because here this radius vector is small, so it will be moving much faster, and this area will still be equal to this area. The second law is clear to everybody? Just write yes or no in the chat. So both the law, first and second law, are clear to everybody? Okay, good. So basically, the way we can try to remember is that first law is about the focus points. Okay, or the first law is about the foci. That means the sun is always at one of the foci when the planets are revolving around the sun. Okay, the orbit is elliptic and the sun is always at one of the foci. And the second law is that the radius vector. Okay, we can just say joining any planet and all that, you don't need to remember. The radius vector sweeps equal areas and equal length of time. So basically that this area is equal to this area. So when the planet is away from the sun, it is moving at a slow speed, and when the sun, it is closer to the sun, it will be moving at a larger speed. Okay, so that is what it simply means. Okay, let's go to the other laws. Now, okay, do you remember what is the aphelion and perihelion?
Yes, sir.
What is aphelion?
Sir, when Earth is closest to the sun.
Who is that? Pawan Dixit? Hmm? Who was that? Pawan Dixit? I could make
Yes,
out the
sir.
voice. Yes, okay. Yeah, so farthest from the sun, Shubham Kadam is saying, in which one? Aphelion or perihelion?
Aphelion.
Huh?
Aphelion. Aphelion. Aphelion.
At aphelion, it is the farthest from the sun.
Yes, sir.
Yeah, I think so. Okay. So, where is that? Ooh. Okay. 1 minute. Huh? I have not given here. Yeah. At aphelion, it is 94.4 million miles, and perihelion, it is 91.3. Okay. So, it is basically the aphelion time, the distance is more. And same way, apogee, the distance is more than the perigee. Apogee and perigee we refer with reference to the moon. Okay. And perihelion is, with reference to the sun, because it is, the sun is also called helion or helium or something. Helion, I think. Okay. So when we are when we're comparing the distances from the sun, that reference will be aphelion and perihelion. Okay. And when it is with reference to the moon, it will be apogee and perigee. And with reference to the earth, there is another term which I'm forgetting now, something with G or Geo or something. Okay. So that is what it is. So that's what I said. For equal areas to be swept out in equal periods, the planet moves faster in its orbit when they are closer to the sun and slower when it is further away. Okay. The planet is said to be aphelion, perihelion. This we have already gone through. The average distance between the sun and the earth is 93 million miles, and eccentricity of the Earth's orbit is about 1:60. That means that the Earth's orbit also is not exactly circular, it is also eccentric. Now, okay, for the Earth it is, yeah, helion, suffix is G from the Earth. So for the, yeah, okay, when we are comparing the distance from the moon and the Earth, that is why we say apogee and perigee, because in comparison to the, with reference to the Earth, and whereas for the distance when we are comparing or when we are stating the distance with respect to the moon, there will be apollyon or perihelion. Okay, for lunatic याद रखोगे तो याद हो जाएगा. Huh? So it is apollyon and perihelion, and when the distance is measured from the Earth, it will be perigee and apogee. Now third law. Now, third law is giving the distance, the relationship between the distance of the planet and the time it takes to complete one revolution. Okay. So the two things involved are how much is the distance from the sun and how much time it is taking to complete one revolution. Okay. So the Kepler's third law is basically giving us a relationship. Relationship means basically is giving us a formula. Like what is the relation between the distance and the time taken by that planet to revolve around the sun. So what that relation or the formula is given by the Kepler's third law. According to this law, planets which are closer to the sun have a greater angular velocity than planets which are further away. Now, what is the meaning of angular velocity? Why it is not written velocity?
Velocity is used when you're moving a straight line.
But here also it is written velocity, no?
Sir, because it's a rotating body.
Yeah, simple thing, because going in an angle, no? Is basically coming from some degrees or angles. That's why we are talking in terms of angular velocity. Velocity is still this, the distance only, but it is going around in a circle or ellipse or whatever you want to call it. My main reason for asking this was that the concept should be clear, like why we are writing here angular orbital velocity, okay? And what is velocity and why we are saying angular velocity here? Because basically we are covering up the angles, how many degrees in one day or one month or 1 year, okay? So that is what is the angular velocity. Like when we say one revolution means 360 degrees. Okay? So basically, that is what this third law is giving us, the relationship between the distance and the time taken. Now, what that is, let's see. Now, that third law is the square of the sidereal period of the planet are directly proportional to the cube of their mean distance. Okay. The square of the sidereal period, let's say for the Earth, it is taking, 365 days, the sidereal period. Or what is the sidereal period for the planet? Sidereal period is actually, I think, 24 hours. Okay, sidereal day is 24 hours and sidereal period is 1 year. So for the Earth, you can say period is 1 year. Okay. So the square of the sidereal period, square, that means one square is directly proportional. So is that to the cube of the mean distance. And what is the distance for the Earth? It is always in the reference to the Earth. So that's why they mentioned it here as 1. Okay. So it's all in relation to the Earth. But okay, so let's say for the period of Mercury, it is 0.24 year. So 0.24 will be about how many days? "86 days. Okay. So basically, Mercury is revolving around the sun in 86 days. Okay. So the period of the square of the period is 0.24 into 0.24. Actually, it is 0.05, but probably, it is the distance is maybe 0.24 something. And that's how they have put the square as 0.06. And the mean distance is 0.39. I will have to check, what units they've used. And uska cube karenge to it becomes 2.06. So that ratio, if you see, is always as 1. So basically, the square of the period and the distance, cube of the distance. If you take the ratio, it will always be the same for each of the planet. Okay. So this is little bit, like maybe you will find little hard to kind of remember or relate. But this is the third law, that the square of the sidereal period of the planets are directly proportional to the cube of their mean distance. There are 2 planets which in particular you can remember. One is the Jupiter, which is 12 years, about approximately 11.86, but we consider it 12 years. And the Saturn is about 30 years. That means Saturn is taking about 30 years to complete one revolution around the sun. And Jupiter is taking 12 years to go around the sun. Okay. And Mars is taking about 2 years. Earth is taking, of course, we all know for the Earth that it is taking only 365 days, and that is 1 year. So basically, the period they are calculating in the year. I mean, even if you take it in days, also it would give you the same results. So that was the third rule, Kepler's third law, not rule actually, the third law. Okay. So just take a this thing, a snapshot or take a screenshot and just try to go through these rules. Okay, so that you can remember them. I think I finished with this topic of rotation and revolution of the planets. And tomorrow, 1 minute. Yeah, tomorrow I think we have a lecture tomorrow also. So we'll go through that topic of equinoxes and solstices. When is the summer solstice? For the
21 June.
For the what is that? Just put down in the chat for the this northern hemisphere for this 2020. When is the summer solstice? Yes, very good. It was yesterday. Yesterday on 21st June was the summer solstice. So basically now the sun has started to move towards the equinox, which will happen on 23rd September. Okay. So yesterday was the summer solstice, and now the sun is already moving towards the equinox. And so next topic will be our solstices and equinoxes, which we'll cover tomorrow. For the time being, for today, I will just what we have done so far today is that what is the solar? I mean, in the solar system, what all things are there? So most important, of course, is the sun, which is also rotating on its own axis in about 25 days. And all other planets are also rotating on their own axis, and they take different time. And also they are going around the sun in different time. Okay. I mean, they are completing their revolution in different periods. For the Earth, it is 1 year. For Mercury, it is 0.24, Venus 0.62, like that. Jupiter about 11.86, Saturn 29.5 years to complete one revolution around the sun. Then there are 3 laws given by Mr. Kepler. Okay, I think almost 400 years ago, these laws were framed by scientist Kepler or astronomer. Okay, so the first law is that all the planets are going around the sun in an elliptical orbit, having the sun at one of the foci. Okay, now that was the first law, that all the planets are going around the sun in an elliptical orbit, having the sun at one of the foci. The second law is the radius vector, which is joining the sun and the planet. Radius vector sweeps equal distance or equal area, not distance, equal area in equal time. Okay, that means when the planets are closer to the sun, they are moving faster, and when they are away from the sun, that means when they are at aphelion, they are moving slower. At aphelion, when the distance is more with respect to the sun, they are moving slower, and when they are closer to the sun, that is in perihelion, that is the time they are moving faster. So those were the 2 laws, and the third law, which came, almost 10 with the 10 years of gap. That means he framed 2 laws, and the third law he gave almost after this thing, a 10 years gap. And this third law is that the square of the sidereal period, just remember sidereal period for Earth is 1 year, and sidereal day. Sidereal day is 23 hours 56 minutes. That you will slowly learn also, like why we call it 24 hours. Sidereal day is 24 hours and sidereal period is 1 year or 365 days. So that square of the sidereal period of the planet is directly proportional to the cube of the distance. Okay, so distance cube of the distance is directly proportional to the sidereal period. Okay, sidereal period of some of the planets, if you can remember, for the Earth it is 1 year, for Jupiter 12 years, for Saturn 30 years. You know why I am saying all this is because if you take a little bit in the, the astrological predictions, if you read, you will see, when the sun is moving or when the Saturn is moving, you will see in each zodiac is there in about 2.5 years. So it's very easy to remember, 30 years. So Jupiter is staying in one zodiac for 1 year. So that is about 12 years. It's completing one revolution around the sun. Okay. So for Jupiter and Saturn, very easy to remember. Mars also. Mars is a few months it is staying in one zodiac. Okay. So you can relate it like that if you want to. Okay. Just to remember like how much is the sidereal period of each planet. Okay. So that is all. Any questions for today? Let me take the attendance. If you have anything, any question, just put down in the chat. Why? I'm surprised why only 23 people are joining the lectures. Who is the class monitor?
Yes, sir.
Why only 23 people are joining the lecture?
Sir, they have network issues.
But how come only first year boys are having network issues?
Sir, most of them are in their village.
Village में तो आजकल अच्छा है. Anyway, just remind them once again that they will have to attend all these lectures again. Huh? And,
Yes, sir.
Okay, so do we use celestial navigation on board in present day? Of course, yes, we use. We do take sites. At least we have to keep in touch. And whenever there is an inspection, they want to see. It is not that we are not using celestial navigation. We are taking sights of the sun. Moon is not used for sights, but sun and stars, you can use it. In fact, we are supposed to maintain a book and take regular sights. Okay. So don't be under the impression that, all this is useless. No, we are still using celestial navigation. Okay. Yes. Anything else? Just quickly say yes or no on the chat so that I can finish the meeting. If you have any more questions, just say yes or no in the chat quickly. Okay, so most of the people, they have no doubt. So I'm going to be stopping the sharing and okay, I'm going to stop the recording also.